through the mathematics numeracy paper for Unit 1, non-calculator higher tier from the summer of 2018. The important thing to say is that I am going to skip the first 7 questions because I've already done them in the intermediate paper, so there'll be a link below. And if you find these videos useful, please feel free to subscribe and you will get access to any videos when I upload them. Okay, so the first question for the higher tier was question 8. It says, this lady works for an accountancy firm. She receives an annual salary which is paid in equal instalments. She has calculated that so far this financial year, she has been paid 0.416 recurring of her salary. Express this fraction in its lowest terms. Okay, so the way that we do this, or the way is I write down x, so I leave a couple of lines. I say x is equal to that fraction in non-reoccurring form. So I say 0.41666, and so on. That's what that means. That's what that fraction is. Now, however many reoccurring dots there is how many is an indicator of what I'm going to times this by. Okay, if there is only one reoccurring dot, I'll times by 10. If there are 2 reoccurring dots, I'll times by 100. 3 reoccurring dots, I'll times by 1,000. There's only one dot, so I'm going to times by 10. I'm going to write it above, but I'm going to take special note to keep my equal sign and my decimal point sign in exactly the same place. X times 10 is 10x, and then 0.4166666 times by 10 would shift everything across one place to the left, so it would become 4.16666, and so on. Okay. Now, when I take these two equations away from each other, again, line up your equal sign, line up your decimal point. 6 take away 6, cancels, 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 cancels. 6 take away 1, 5. 1 take away 4, be careful, you probably haven't done this for a while. You borrow 1 from the next place to the left. 11 take away 4 is 7. And then 3 take away nothing is 3. And just be careful with this bit here. 10x take away x would be 9x, not 10. Okay. Then I need to change it into a fraction, which is 3.75 over 9. Now, there's a big problem with that. It's not a fraction, so I've got a decimal in it. So what I need to do is times the top by 100 and times the bottom by 100 to keep it equivalent. So x is equal to 375 divided by 900. Now, ordinarily with these type of questions, we are just asked to express it. But they want me to put that in lowest terms. Now, I know that's not in lowest terms because it ends with a 5 and a 0. That means 5 must go into it. How many 5s go into 375? Well, into 300 would be 60, into 75 would be 15, so 75. So I'm going to say x equals 75. And how many 5s go into 900? Well, it's 20 for every 100, isn't it? So 20 times 9 would be 180. Again, ends in 5 and 0, so I'm going to divide by 5 again. So that's going to be 15 over 36. And then I can divide both by 3. So x is equal to 5 over 12. Okay. Again, that's in lowest form now because there's no number that can divide into both. It then says, use your answer from part A to find the number of months of pay that she's received. Well, if it's of her annual salary, annual means every year. So 1 year, in a year, there are 12 months. And if she's received 5/12 of it, she must have had 5 months pay. Okay. Question 9. Mattis knows the following information about the fuel his car uses. Speed, miles per gallon. When he drives at 30, his car uses 54 miles per gallon. When he drives at 50, it uses 60 miles per gallon. 70, 50 miles per gallon. During one journey, Mattis drove 50 miles an hour per hour for part of the time and 70 for the rest. He drove 3 hours at a speed of 50 miles per hour. The whole journey, Mattis used 4.6 gallons of fuel. For how long was he travelling at 70 miles an hour? You must show you're working. And it's 6 marks. There's a lot of marks going on here. The first thing I can see is that this is a speed, distance, time question. So speed is equal to the distance divided by the time. So you might be used to drawing in this triangle. Okay. Now, in terms of tackling a question like this, go through it line by line and see if you can start working things out here. Because if there's 6 marks available, you're going to start picking up marks if you can start calculating some things here. We're told he drove for 3 hours. So I can work out the distance by covering up the D. It's going to be speed times time. So I'm going to say distance is equal to the speed. So speed was 50 miles per hour times by the time, which is 3 hours. So it's going to be 50 times by 3, which equals 150 miles. He did 150 miles at 50 miles per hour. Okay. Now, I know here from this table above, it says that when I'm driving at 50 miles per hour, I'm going to be using 60 miles, or for every 60 miles I travel, I'm going to use a gallon of fuel per gallon. So if I do 150 divided by 60, I'll work out how many gallons of fuel that used. So I can see that they both end in a 0, so I'm going to divide top and bottom by 10. And then how many 6s go into 15? So 6, 12, 18. So it's between 12 and 18. In fact, it's bang in between 12 and 18, so that's going to be 2.5. And that's 2.5 gallons of fuel used at 50 miles per hour. Okay. Now, we're told in the question that for the whole journey, we use 4.6. So I've just worked out that for that 50 miles per hour bit, we've used 2.5. So if I do 4.6 and I take away 2.5, I'm going to find out there's 2.1 gallons used at 70 miles per hour. Okay. Now, in terms of what I want to do now, if I look back at my table, I know that for every gallon of fuel that I have, I'm going to go 50 miles at 70 miles per hour. So if I do 2.1, so if I do 2.1 times by the 50 in the table, that will tell me how many miles I travelled at 70 miles per hour. So 2.1 times 50, I can't do that off the top of my head. I don't know how to. So I'm going to times that by 10 and divide that by 10, which is a trick I've used in different videos. If I make something 10 times bigger than 10 times smaller, it's still exactly the same thing. 21 times 5, I know very quickly. It's 105 miles at 70 miles per hour. Okay. Now, the one thing that I tend to do is think, oh, right, I've done the question. Let's just double check what it says. We travelled a distance of 105 miles at 70 miles per hour. It says, the question, it says for how long did he travel? How long, that's time. Okay. So to work out the time, I need to do distance divided by speed. So the distance that I travelled was 105. So let's say time equals 105 divided by the speed divided by 70. Now, in terms of working that out, we could divide top and bottom by 5, so that would give me 21 divided by 14, and then divide both of those by 7 to get 3 over 2, which we're more used to seeing as 1.5 hours. Okay, and question 10 I thought was quite hard as well. They're not easy, the questions in this paper. They are all quite tricky now. You're going to have to read that question, pause the video for a second, and I'm going to start going through it, okay? Okay, then. So it says, astronomers use the astronomical units AU to describe the distances in our solar system. The distance between the sun and the Earth is 1 AU. Let me just focus that a bit more clearly. There we go. 1 AU is 1.496 times 10 to the 8 kilometers per corrector for significant figures. The distance of Pluto from the Sun is 5.913 times 10 to the power of 9 kilometers correct for significant figures. Sean says the distance of Pluto from the Sun is less than 50 AU. Using suitable approximations. Now, for me, the estimating question, okay, so it's about being able, oh, look, there we go, estimate the distance. they usually put those words in bold. But because there's so much text going on, it's very easy to miss that this is an estimating question. Okay. Now, in that case, then, we want to use suitable approximations. Now, normally, I would tell anyone to round this to one significant figure, but they want me to use suitable approximations. They want me to be really close to it, okay? So 1.496, ordinarily, I'd round to 1, but 1.496 is ludicrously close to 1.5. So I'm going to put there is approximately equal to 1.5 times 10 to the 8, okay? Similarly, here, I'm going to put an approximation for that. Again, 5.913. Round to one significant would be 6, but again, it's really close to 6. That's a good, suitable approximation. Okay. Now, in terms of the world, we know that we're quite close to the sun. If that's Earth, we know we're this distance here, which is 1 AU. Let me just say that's Earth. Which is 1 AU, which we've just said is 1.5 times 10 to the 9.8. We're then asked to estimate the distance from Pluto to the sun in AU. So what we want to do is work out how many of these things, which is 1 AU there, how many of those fit into that. So we've got a dividing question here. We want to do 5.913 times 10 to the 9 divided by what 1 AU is, which is 1.496 times 10 to the 8. But we obviously can't do that, so that's where we approximate. So we're going to say that's 6 times 10 to the 9 over 1.5 times 10 to the 8. So your standard form now kicks in. How many 1.5s goes in 6? So I can put equals now. It's not an approximation now. I've approximated that to get that. Now I'm actually working that out, so we're back to straight equal signs. How many 1.5s go in 6? So 1.5, 3, 4.5, 6. So that's 4. And then times 10 to the power of 1. Okay, subtracting the indices. 4 times 10 to the 1 is just 4 times 10 is 40. He said it was less than 50. He's correct. Now, usually it just says, is he correct? So they tell us to show that he's correct. Well, we have shown that he's correct, but they usually ask us, or it's not a bad idea to say something like, yes, Sean is correct. As that's what usually happens in a numeracy paper. You usually have to state whether they're correct or not. Okay. The next thing we're asked for here is, what's it say? It says a light year is the distance light travels in 1 year. 1 light year is approximately 63,000 AU. Okay. Estimate the length of light. So again, we've got that word. They've not bolded it. Sorry, my computer froze then. Again, we've got the word estimate here. So we need to make sure that is highlighted. So we don't have to use the exact numbers. We can't because we haven't got a calculator. Estimate the length of the year in kilometers. Give your answer in standard form. Now, we know that 1 AU is equal or is approximately equal to 1.5 times 10 to the 8. I want to know what 63,000 AU is approximately equal to. Okay. Now, to do that, I need to times this side by 63,000, which is quite easy. I've just gone and worked it out. 1 times 63,000 is 63,000. But now I need to do 1.5 times 10 to the 8 times 63,000. So coming over onto the other page, I'm going to say this 1.5 times 10 to the 8 times by 63,000. What I'm going to do now is change that into standard form. So I know it's got to be a number between 1 and 10. So I've put the decimal in between the 6 and the 3 to make it 6.3. And then how many numbers would come after that decimal if I did put it there? 1, 2, 3, 4. So that's times 10 to the power of 4. Put a bracket around that. Don't need to do that, in all honesty. And the way that you solve these then is that the numbers deal with the numbers. So we do 1.5 times 6.3. And then the 10s deal with the 10s. So we do 10.8 times by 10 to the power of 8 times 10 to the power of 4. So that's the easy bit. That's times 10 to the power of 12. Okay. The harder bit is working out what 1.5 times 6.3 is. I'm going to show you what I think is a clever way to do this. 6.3 times 1, I know what that is. 6.3. Leave a space. 6.3 times 2, I know what that is. That's 12.6. So what's 6.3 times 1.5? Well, that's bang in between 1 and 2. So the answer must be bang in between these numbers. What's midway between 6 and 12? 9. In between 0.3 and 0.6? 0.45. Okay, so 9.45 times 10 to the 12. Okay, question 11. pause the video, have a quick read of the question, try and get your head around it, and then I'll start talking it through. Okay, it says, during a chemistry experiment, it was found that a particle lost 3/4 of its mass every second. The initial mass of the particle was 160 milligrams. Calculate the mass of the particle after 4 seconds, circle your answer. Well, if it's losing 3/4 of its mass every second, that means it is a quarter of what it was originally. So to work out what it will be after 1 second, I'd do 160 times by a quarter. So that would be just dividing that by 4, which would be 40 milligrams. Okay, so that's after 1 second. Then I want to do 40 times by a quarter, which would be 10. That's after 2 seconds. Then I'm going to do 10 times by a quarter, which is equal to 2.5, which would be after 3 seconds. So after 4 seconds, it is going to be 2.5 times by a quarter. Now, we might be able to start discounting some of these here. It's not 2.5 because that's it after 3. It's not 40, so that's way bigger. So it's between these ones here. Now, to divide this by 4, I'm going to do 2 and 0.5 separately. A quarter of 2 is 0.5, so it's at least 0.5, so it's not that one there. And then a quarter of that would be 0.5, would be 0.25, 0.125. So putting those two together would give me 0.625, which is an option there. We knew it couldn't be that, it was too big. Okay, it then says, write down a formula for mass in milligrams after t seconds. Now you will notice here that I have my mass, so my 160, and I basically just repeatedly times by a quarter, times by a quarter, times by a quarter, times by a quarter. Now I did that 4 times because it was 4 seconds. If it's t seconds, I would do this t amount of times, okay? In this case, it's 4 because it told me 4 seconds. But if it was, say, 20 seconds, I'd times by a quarter 20 times, okay? So effectively, m is going to equal the mass of what it was originally, times by a quarter, which I might write as 0.25, to the power of t, to however many seconds we're looking. To the power of t, which is how many seconds we're looking for, okay? Okay, question 12. This is one of my favourite ones to do. I always think these are really, really easy, as long as you know the following formula. When we are talking about scale factor and similar shapes, okay, so we can see the word here, similar. I always remember the following 3 formulas. Small times by scale factor equals big. That is for length, okay? Small times by scale factor squared is equal to big. That's for area. Think centimetre squared, think area. And then small times scale factor cubed is equal to big. Guess what that's for? Volume. Okay. Now, I don't have to read a huge amount of this question. I can work out what's going on pretty easily. It gives me 400 centimetres squared, 3,600 centimetres squared. We were talking areas. It says there the glaze covers an area of this. So the small one, 400, times by the scale factor squared, which I don't know, so it just says as SF squared, equals 3,600. I'm now going to divide by that 400 to get scale factor squared is equal to 3,600 divided by 400. Divide top and bottom by 100. 4 goes into 36 9 times, so scale factor squared is equal to 9. So the scale factor is 3. Okay, now what that means is that the length of the small vase will be times by 3 to get this number here, and to work backwards, I would do the opposite of times by 3, which would be divided by 3. Next, it says calculate the height of the smaller vase. So this one here, it wants to know what this length here is. Okay, so to go from the bigger vase to the smaller vase, I do 48 divided by 3. And 48 divided by 3 is 16 centimetres. Okay. Question 13. Now, before I've gone too far, I've already seen the word here, frequency density. This is not a bar chart. This is a histogram. It'll say it somewhere. There we go, histogram. It's not going to be as easy as just reading things off simply by the time you get to page 24 of a higher tier exam. You need to know this formula. Frequency density is equal to frequency divided by class width. Now, again, I tend to put this into a triangle because we can rearrange that formula quite a lot, or you can be asked to rearrange it quite a lot. We're then told the following information. there were 24 girls, so the frequency is 24, in year 11 whose heights were between 155 to 160, so that's the class width. The class width is the distance between 155 and 160, which is 5. Okay, so now we know the frequency, and now we know the class width. We can work out the frequency density by covering FD and doing frequency divided by the class width. So we're going to do FD is equal to 24 divided by 5, which is 4.8. Okay, so looking at the graph, there's 4. Next one up is 6. So each of these little squares goes up in 0.2. So 5 is there, coming 1 down from there. Yeah, make sure you do any work in pencil. If you do go wrong, then you can rub it out in the exam. Okay, now over the page, it says, Nia has done some data analysis on the heights of year 11 girls. She has estimated the median and the upper quartile as shown in the table below. Now, the median is the middle person, the upper quartile is 3/4, lower quartile is a quarter, okay? So I'm going to say here, quarter, a half. The donkey work for us here, in all honesty. We need to go and work out a quarter of the total number of people. The problem is we don't know the total number of people. What we do know is we know there's 24 people in that category there because we just did it. And you would work that out by saying frequency, so cover that up, is equal to the frequency density, so 4.8, so I just worked out here, 4.8, times by the class width, so times by 5, 4.8 times. Okay, now in terms of working out the others, I need to look at the class width, so that was 10, and I do 10 times its frequency density, so 1, 2, 3 little squares up would be 0.6, so 0.6 times 10 would be a total of 6 people in this bar here. Frequency density, much easier this time, is 2. Class width again is 10. 2 times 10 is 20. And then for 145 and 150 is class width of 5, 6. 5 times 6 is 30, so it's 30 in this bar. Frequency density of 8, class width of 5. 8 times 5 is 40. And then finally, frequency density of 1, class width of 20. And tell me that is 20. Okay. What I need to do now is work out the total number of people. So that's going to be 6 plus 20 plus 30 plus 40 plus 24 plus 20. Now, we haven't got a calculator in this, so let me show you a couple of tricks that I do when I'm doing it, looking explicitly for number bonds. So that makes my life a little bit easier to start off with. So 6 add 24 is 30. 30 add 30 is 60. So I've now included that. 60 add 40 is 100. Add 20 is 140. Okay, so I've just made something that could actually be quite a long, cumbersome job, reasonably straightforward. 140. Okay, now we know that the median was equal to the 70th person. Okay, that means the lower quartile must be the 35th person. So coming back here, I'm looking for where the 35th person would be. So the 6 people here, up to 26 are in here, and then up to 56 goes here. So it's somewhere in this bar here. So I'm just going to draw a line down here. Now, although it's on a line, I don't actually know how big that class width is. Okay, but what I do know is I know that we've had 26 people already accounted for here. I'm looking to get to the 35th person. So 26 add what will make 35? 9. So effectively, I'll split that up into a 9 people in this bit of the bar and 21 people in this bit of the bar. What I need to do is work out how wide this bar would be. I need to work out its class width for that new bar. Okay, so class width would be equal to the frequency, so 9, divided by the frequency density, 6. Okay, so I'm going to say here, class width equals frequency, which we said was 9, divided by the class width, divided by, got myself confused now. The class width is the frequency density. Find the frequency, divide by the frequency density. So divide by 6, which was the frequency density over there. Okay, 9 divided by 6 is 1.5. So that is a distance of 1.5 on from 145. So that must be 146.5. So an estimate then for my lower quartile would be 146.5. Okay, on to the final question of the numeracy paper. Okay, so we've got a lot of information to read there. Make sure you've had a quick read through. Okay then. So it says in the diagram below shows a simplified model of part of an engine. It shows the belt which runs around 3 circular cogs. The engine rotates around cog 1 rotates around the belt, which then makes cogs 2 and 3 rotate. And you can see they're all different sizes. We're then told A, B, C, D, E, F. So if you have a look at E, F, A, B, C, D, they're all straight lines. Yeah, we can see as much in the diagram, so not really that important. And they told us those lengths that's already in the diagram. Okay, so nothing to worry about here. The belt bends around the outer edges of the circular cogs, represented by arcs A, B, D, E, A, F. So again, we can see that in the diagram. The dimensions of the cogs are radius cog 1 equals 6. Now, they haven't told us that. I'm going to go and write that in. That's 6 centimetres there. That's 6 centimetres there. Okay. We're then told cog 2 is 4.5, so it's slightly smaller. 4.5 centimetres there. 4.5 centimetres there. And then cog 3 is 3 centimetres there. So half the size of cog 1, 3 centimetres there. It then says, what is the length of AF? So let's go and work out where AF is. There's A, there's F. Go and work out what that arc is there. Okay. Now, that arc would be worked out as follows. It's part of the circumference. So we're using the circumference formula, which is 2 pi r. But we would multiply that by... Oh, hang on. You're not seeing what I'm writing. Okay, so, sorry, I've just moved the visualizer so that you can see what I'm writing. So this bit here is part of the circumference. So I'm using the circumference formula, which is 2 pi r, but I'm going to times it by the angle, which would be 90, and then out of 360. Now, alternatively, 90 out of 360, I can quite clearly see, split that into a quarter of a circle. Hence, it's going to be a quarter of the radius. Okay? Not quarter of the radius, sorry, quarter of the circumference. Okay? Now, from here, I know the radius is 6. I've been told that. So I want to do a quarter of whatever 2 pi times by 6 is. Now, 2 pi times 6 would be 12 pi. And then 12 pi, find a quarter of that, would be 3 pi. So 3 pi is the distance there. That's what we should be selecting. So the first thing I'm going to do there is write in simplified form. That distance there is 3 pi. If you look over the page then, it says, can you work out the total length of the belt? Give your answer in terms of pi in simplest form. So what I need to do is work out similarly here what that arc is there and what this arc is here. Okay. Now, we want to use exactly the same way I've just done that, but we'll have to work out how much of the circle is represented. Now, this is quite a nice one as well. 120 goes into 360, the full circle, 3 times. So this is a third times by 2 pi r. And the radius is 4.5. So 2 times by 4.5 is 9. A third of 9 would be 3 pi. It's actually exactly the same length. So that's 3 pi as well. This one's going to be the hardest one because it's not an obvious part of the circle. For instance, 150 doesn't go into 360. So what I do is I say 150 out of 360 times by 2 pi r. So 2 pi times 3. I can work out what that 2 pi times 3 is. That's 6 pi. And then 150 over 360, I'm dividing top and bottom by 10 to get 15 over 36. I'm now going to divide 15 and 36 both by 3, because I know 3 goes into both. So that's going to be 5 out of 12. So that's 5/12 of 6. Now again, this is all just one continuum here. I'm going to divide top and bottom by 6. So we're going to get 5 times pi over 2. So that is 5 pi over 2 or 2.5 pi. Okay, now from there, the total length of the belt, so I'm going to write all the long measurements. So 29, add 12, add 34, they were just the straights. And then I'm going to add in 3 pi, add 3 pi, add 2.5 pi. Okay, now the pi is the easiest bit to work out. That's going to be 8. Oh, I can't even write it out though. I say it's easy, I've just messed it up. 8.5 pi. And then 29 plus 12. If we add on the 2 first, we get 31. 31 plus 34 is 65. Not forgetting that 10 there, 75. I make that. Again, you may not like the way I did that. They're just 3 numbers, add them together. And that's the length I've worked out there. Now, the last question, which is part C, is I hate these sort of questions. I always find these really hard to get my head around what's going on. It says, Ellen notices that cog 3 makes 2 revolutions, or when it makes 2 revolutions, cog 1 only makes 1 revolution. This is because the radius of cog 3 is half the radius of cog 1. So let's just look at it again. That's 3 centimetres, that's 6. So when that does 1 full turn, that will have done 2 full turns because that is half of that, okay? So what I'm going to say here, cog 3, to work out how many revolutions cog 1 will make, I will times it by a half, because 3 divided by 6 is a half, okay? We're then working with cog 3 again, but this time we're going to cog 2. Now, it's a little bit hard to spot the ratio here. Now, that half was 3, I can't write again, 3 divided by 6. That's how we worked that out. We said the radius of cog 3 divided by the radius of cog 1. Now, because we're going cog 3 to cog 2 again, what I want to do is the radius of cog 3, so 3, divided by the radius of cog 2, 4.5. 3 divided by 4.5 could write much more easily as 2/3. So I need to times the 2,400 by 2/3 in order to work out the number of revolutions. Again, let's just look at it logically. We know that for 1 full turn of that makes twice as many. So say that's done 10 turns, that's done 20. This one's done less turns because it's bigger. So again, this one here should do less turns because it's bigger. So if this has done 2,400, if we find 1/3, so I'm going to say 1/3 of 2,400 is equal to, I'm not going to have my equals there, I'm going to have it there, is 800. Then 2/3 would be twice as much. So 2/3 would equal 1,600, which is less than 2,400. So again, logically, that makes sense. Okay. Hopefully you found this video useful. If you did, please hit the subscribe button, and you'll have access to any more videos that I release. Thank you very much. Keep up the good work.